Hey guys, welcome back. We are going to be talking about Unit 1, Target 3, that's simplifying expressions using order of operations. Now, order of operations is probably something you've seen before, and a lot of the stuff we're going to talk about today might be very familiar to you, but we're probably going to talk about a few things that might be a little bit new, or we're using them in a different way. So, let's dive right in here. Now, most of you have probably heard about order of operations in the form of an acronym called PEMDAS, and PEMDAS stands for parentheses, exponents, multiplication, division, addition, and subtraction. And when we look at this vertically, it looks like there are 6 different levels to our order of operation. And this can work for you, and if you've got this down and you can do problems correctly, then fine, stick with PEMDAS. However, we do have to be cautious. Just like somebody around, an angry gamer has to be cautious, right? Your friend's playing League of Legends, he goes bot, the rest of his team goes mid when they were supposed to go bot, he gets angry and starts throwing things. You got to keep your head on a swivel. You got to be aware. Because what is the most common sentence that we've learned to help us remember this acronym of PEMDAS? It's please excuse my dear Aunt Sally. And we all love dear Aunt Sally, right? She has soap, milk, and cookies. We go do arts and crafts. We watch movies. She's great. Here's the problem. Your dear Aunt Sally isn't really your dear Aunt Sally. She's actually a zombie. She doesn't want to have you over for milk and cookies. She wants to have you over to eat your brain. Okay, well, maybe your dear Aunt Sally isn't really a zombie. But here's the danger of PEMDAS. We've got to be careful. It appears when we look at PEMDAS vertically that multiplication always comes before division and that addition always comes before subtraction, and this is a lie. And if you buy into this lie, it can very easily wreck a lot of problems for you and lose you a lot of points when we're trying to simplify our expressions. So how can we avoid this? Well, one acronym that we feel is a little bit more helpful is the acronym GEMMA. Now, GEMMA has only 4 levels, as you can see here. The first level is grouping symbols. Now, parentheses are a grouping symbol, but we're going to have a few more, and we'll talk about that in just a minute here. The second level is exponents. That's the same. The biggest change comes in the third and the fourth levels here. We can see that addition and subtraction and multiplication and division are on the same levels there. Multiplication and division on the third level, addition and subtraction on the fourth level. They are equal. One does not necessarily come before the other. So let's look at GEMMA in a little bit more detail now. So grouping symbols. We've got 4 different kinds of grouping symbols now. Not just parentheses, we also have brackets and braces. Now brackets and braces are exactly like parentheses, just a different shape. The reason we have different shapes is in case you're working in a long expression with lots of different grouping symbols that you can kind of tell the difference between them, so we have different shapes. However, when we get to absolute value, it's still a grouping symbol, but it's like the mutant grouping symbol, right? It's got a special power, special ability that it has. Kind of like Wolverine, Storm, Cyclops, like the X-Men, or whatever superhero you like the best, except for probably Batman, because we know Batman has no powers. And we'll talk about absolute value here in just a next slide here in just a minute and go into more detail. But let's talk about the M and the A level there, the third and the fourth level. So how do we know which one comes first, multiplication or division or addition or subtraction? Well, we are actually just going to read from left to right, and if we're trying to decide between multiplication and division, we decide first whichever one comes first. Same thing with addition and subtraction. If I'm reading from left to right and subtraction comes first, I do the subtraction first. If addition comes first, I do the addition first. We're going to look at some examples in a little bit here that really highlight this difference between GEMMA and PEMDAS. So if you have some questions now, don't worry. We'll get there and we'll look at some examples. So as I said, let's talk about our mutant grouping symbol here, absolute value, right? Now absolute value is the distance a number is from 0, right? That's kind of what we think of as the middle of our number line. We don't really have a middle, but it's kind of the point we kind of think of as the middle here. So if we look at our number line, we can see we have 2 numbers on the number line, 3 and -7. The distance to go from 0 to 3, if I were to start at 0 and run to 3, I'd be running 3 units. So the absolute value of 3 is positive 3. If I were to start at 0 and run to -7, I would be running 7 units. That's the distance it would take me to get there. So the absolute value of -7 is positive 7. You might be asking, why are all the absolute values coming out positive? It's a good question. Let's talk about that. So we said that absolute value is a distance. And one thing we've got to understand about distance is never negative. One easy way we can see this is with cars, right? This is why there's a picture of Lightning McQueen there. It doesn't matter if Lightning drives forward or if Lightning drives backwards. He is always traveling a positive distance. And if you want proof of this, either sit shotgun or if you're old enough to drive, look at the odometer. That's the number counting thing that keeps track of the number of miles a car has. It doesn't matter whether you go forwards or whether you go backwards. The number of miles is always going to go up. I don't know why this keeps doing this, guys. I apologize. Hopefully this message won't come up again here. The number of miles will always go up. It'll never go down because distance is never negative. So if absolute value is a distance and distance is never negative, then what we can conclude is that our absolute value of a number is never going to be negative. It could be 0. You could go nowhere, right? But you can't go a negative distance, which means we can't have a negative absolute value. So let's take a look at an example and actually work with our absolute value bars here. So we've got the absolute value of 6 minus 14 plus 2. Now we know with our grouping symbols, I've always got to simplify inside the grouping symbols first. So that means I've got to do the subtraction, the addition, before I can use the mutant power, the special power of absolute value here. So we've got 6 minus 14 plus 2. Which do we do first, subtraction or addition? Well, we know from Gemma, we do whichever comes first from left to right. So subtraction comes first, so I do 6 minus 14 first. That gives me negative 8 plus 2. Now I can do the addition, and I get the absolute value of negative 6. Since I have simplified everything inside the absolute value now, down to one term, I can now take the absolute value of negative 6, which is positive 6. And what we did here is something very important to remember. We always have to simplify everything inside the absolute value bars down to one term before we can apply the absolute value, before we can kind of use its special power. And that's something that's really important. If you have questions on this, we are going to see some examples with this in a little bit, but I want to make sure that you're writing those questions down and bringing them to class so we can have a good discussion if absolute value is a little bit confusing for you. Well, now that we've talked about absolute value, let's actually go on to simplifying some expressions. And what does the word simplifying mean? That might be something that's a little unclear. Well, if we ask you to simplify something, what we're really saying is we want you to perform all possible operations. If there is an operation, addition, subtraction, multiplication, division, exponents, right? We want you to perform and simplify that operation. So as we look at these examples here, it's important to identify the operations that are in these examples. So for the first one, we can see that we have subtraction, multiplication, and addition. We have 3 operations. So how are we going to simplify that? Well, Gemma tells us multiplication comes first, 2 times 3. Then subtraction and addition are equal, so we go from left to right. 3 minus 6 is negative 3. Negative 3 plus 5 is positive 2. In our second example, we have 4 operations: exponents, division, multiplication, and subtraction. Gemma tells us exponents comes first, then division and multiplication are equal. We go left to right. We do the division first. 45 divided by 9 is 5. Then 5 times 5 is 25. Then we finally get to subtraction. 25 minus 4 is 21. In our third example, we've got a couple of pairs of grouping symbols here. We've got the parentheses and then the absolute value bars. We're always going to work inside out with our grouping symbols here. So we're going to do the parentheses first. 30 divided by 6 is 5. Then inside the absolute value bars, I've got 2 operations, addition and exponents. We do exponents first, so 5 squared is 25. 5 plus 25 is 30. Now I can use the special ability, the mutant power of my absolute value bars, to take the absolute value of 30, which is positive 30. Then I can do 2 times 30, which would simplify all the way down to 60. If you have any questions on these, again, please be writing them down and bring them with you to class. So now that we've kind of walked through some examples together, how about you try some on your own here? So in a second, I'm going to ask you to pause the video and try and simplify, fully simplify these expressions on your own. Then we'll come back and check your answers. Ready? Pause. Welcome back. Let's see how you did here. So check the work and look at the final simplified expression. And we got 14 for number 1, 18 for number 2, and 0 for number 3. If you didn't get that, look at the work. Follow the steps. If you've got questions, again, I know I've said this a bunch of times, guys, but it's really important with these flipped lessons that when you get stuck, when something doesn't make sense, that you write it down so you remember the next day, and then come to class and make sure you ask those questions, right? Well, we have reached the end of our video here. The end. right? And if you are having a little bit of trouble with your dear Aunt Sally trying to eat your brains, we can take a tip from the video game. Go buy yourself some plants. Until next time, guys, we'll see you later.